the top of the hour and time to start TLS at IETF 110. First, I want to thank everybody who's joined this edition of our online TLS meeting. Sean and Chris and I are the chairs. You're probably all familiar with the note well, but we'll leave it up here for just a minute so folks can review the IPR policies of the IETF. Okay, so we have minute takers. I think folks would be helpful if people were on Jabber to see what's going on there to make sure we don't miss anything. Blue sheets are now automatic. We don't have to pass anything around. As usual, state your name and your affiliation when talking at the mic. And as always, keep it professional. For the agenda, we have a short presentation on TLS interop runner. Then we'll talk about encrypted client hello, RFC 8446 BIS, deprecating FFDHE, TLS proof of knowledge, and opaque TLS. Are there any other additions? I think that we'll also give a brief document update as well as part of the agenda. Are there any other additions to the agenda or comments on the agenda? All right, great. So other chairs, feel free to step in if I misspeak on this slide. Sean, did you want to?
No, I was going to say go ahead and I'll jump in.
Okay, yeah, so we have a couple of drafts that are in the RFC editor RFC editor queue, which is deprecate old versions TLS and ticket requests. We have requested publication on a number of these. There's a DTLS 1.3. I think that's still in the publication requested state. Exporter authenticators and deprecate MD5 and SHA-1. Do you have any additional updates on these, Sean?
There are a couple of issues outstanding on the deprecate MD5 and SHA-1 that I'm working with Nick to go through.
Okay.
Yeah, DTLS 1.3, I think, literally just went into IETF last call, like last night, right?
No, I think DTLS 1.3 is in ISG evaluation. It was the DTLS 1.2 CID that went to last call.
Yeah, so I have that noted in heading to IETF last call, or was heading until last night, where it's actually in last call now, which is DTLS CID.
Yeah.
Did you have another comment, Ben?
Yeah, you have the DTLS 1.3 listed as publication requested, but I think that is past publication requested, and it's the whole ISG is looking at it now.
Okay, awesome. Waiting for write-up, we have external PSK guidance and delegated credentials. There's still a couple open issues, I think, with delegated credentials that we need to just tie off, and I think PSK guidance may be the same, although I think there may have been a new draft published recently.
Delegated credentials, there's one open issue that we need to address. So I can ping that back to the top of people's lists.
Yeah, we'd like to get those drafts moving forward. We're looking to do a working group last call on flags extension soon. And we have a number of drafts in progress, some of which we'll be talking about today, mainly encrypted client hello and RFC 8446 BIS. All right, unless there are other comments on the document status, we should jump into the first presentation, which will be on the TLS interop runner. Get there.
Could I share my screen?
I'll run the slides unless you have updates, if that's okay.
Sure. everybody can hear me, right? All right, so my name is Gautam Samvada, and I work for the University of Waterloo, and I'm going to talk about the TLS interop runner today, very briefly. Next slide. So to begin with, implementing TLS is not easy, and it does not get easier as new features and new extensions are proposed. And in addition to the usual testing mechanisms, it'd be nice to know that the different implementations of TLS agree with each other on how the protocol and how its extensions are supposed to work. And the spreadsheet on the right is basically concerns a feature known as ECH, or encrypted client hello, and it maintains interoperability data for this feature. And as you might be able to guess, it isn't easy. As there are more like implementations and more TLS features, such as delegated credentials, for example, this becomes more error prone, and it's difficult to scale. And it would be nice to automate everything about this, from the actual testing to the presentation of the results. Next slide. And that's basically where the TLS interop runner comes in. So for example, at a very high level, the way it works is if we have, like, let's say a test case, we want to test server authentication using delegated credentials, for example, the runner starts off by generating some keys and some certificates, and it then passes them to a client and server, which are basically Docker images. The runner then places an NS3 simulated network between the client and the server, and the test is run. The NS3 network captures all of the packets and generates a packet trace, and the client and server output their logs and their keylog files, and then the runner decrypts a packet trace and then checks it to see if the transcript was as what we'd expect of for that particular test case. And if we're considering the example of server authentication using delegated credentials again, then one of the things we'd want to check for is that the client actually did indicate support for delegated credentials in its client flow. And this sort of structure means that adding new endpoints in test cases is simple. And I would be remiss if I didn't mention the fact that this is very much inspired by the Quick interop runner. Next slide. So here's a small demo of what we have so far. This is a work in progress. But as you can see on the left-hand side, we have an automated CI system that basically builds all of the endpoints and then pairs them. It pairs them into client and server pairs, and then runs all of the tests for each of those pairs. Next slide. So basically, to summarize, the TLS interop runner is an automated TLS interoperability testing framework inspired by the Quake interop runner. We're also working on including fuzz, performance, and regression testing using tools such as TLS Attacker. And since we have NS3, we can also use that in performance testing to like drop packets or to add additional traffic and whatnot. And it's a GitHub repository. It's easily available. It can be cloned and run locally. And we're working on a website to present the results. And of course, I should mention that except for third-party code, it is licensed under MIT, and we welcome all sorts of pull requests, comments, issues, feedback. They're certainly welcome. And that's it, essentially. Thank you for listening. If there are any questions, happy to take them now.
Are there any questions?
I have a question. Yes, I'm trying to speak. Did you document this somewhere, or are these hidden somewhere in some script also?
Oh, so right now there's a wiki in the GitHub repository that like documents what tests we have so far. Right now we only have delegated credentials and like 2 basic tests related to encrypted client hello. But yes, once we get the website up and running, we plan to like present that all in a nice aesthetic way.
Okay, cool.
DKG has a question.
I don't know if you can see the chat, Gautam.
Is it? Oh, the process for getting an what is the process for getting an implementation added to this? It's essentially it's adding a Docker file. So we already have like a couple of client and server implementations that, and it's a matter of just copying some of the conventions that they follow, and then yeah, just adding a Docker file to the repository.
Cool.
Steven?
Thanks for, oh, go ahead.
Yeah, sorry, I just realized I did have a question. For ECH, how do you interact with the DNS?
We have like I'm not completely sure. It was Chris Patton added that test case, but I think so. So if you're talking about like resolution, like client and server resolution, we just like those are like sort of hard coded into the endpoints, and we sort of like the endpoints are a client is supposed to connect to like example.com, and that resolution is like taken care of by the interop runner.
Okay, I mean, I'll try it out. That sounds like a great thing. Thanks.
Agreed. I mean, I think this will be pretty useful, especially as we build out more test cases.
Yep.
All right, then. I think we should move on to the next topic, which I think is ECH.
All right. Can you go to the next slide, please? Right. So there was a message that went out to the list a while back to propose moving the interop target from draft 9 to draft 10. There's a PR up right now that includes the changelog between these two versions, and thanks to Martin Thompson for pointing out that we should probably be including changelogs going forward, especially as we now have a primary official interop target. Given that draft 10, or what is now the editor's copy of the draft, uses the quote final version of HPKE, that is the version that won't change test vectors again. It won't likely, unless like something major happens with the protocol past ISRG review, and perhaps additional community analysis. We'd like to. I'd like to propose, just getting the HPKey dependency out of the way, bumping the draft version to 10, ideally today if it's not controversial, and then just moving our interrupt target from 9 to 10. And there was some support for this on the mailing list, but I wanted to pose it to the group now to see if there's any violent objections. As far as I know, most people who are implementing it are supportive of moving forward. But just like confirmation. So I'll pause briefly. If there's any, burning desire to not do so, please let me know. Ben asks if the publication process closed. Do you mean the data tracker? Yeah, as Ecker points out, the tracker's back open for submission, so we can grab the document today. Eric? Ecker, do you have a question? Oh, it's +1. I'm sorry. Plus Q. Can't read. Okay. Great. So, hearing no objections, I'll do so, and then I'll follow up on the thread saying that or with the pointer to the latest version. Then we can go from there. As a reminder, there is inspired by Quick. There is a matrix which has the various clients and servers that we'd like to use for tracking interop results. We're also trying to pull them into the interop runner as well, so we can automate this thing going forward. But as you start bringing up your implementations, please feel free to either add them to the matrix. If you don't have access, request it or leave a comment or so on. And hopefully we can get some good interop results between now and the next IETF version. Next slide, please.
right. So there's a couple of small issues up right now. Some of them have pull requests up, some of them don't. And then there's one whopping issue that doesn't yet have a pull request up that unfortunately it looks like we're not ready to talk about yet. So what I'd like to do now in the time that we have is try to go through each of these smaller issues, just discuss them, see what people think, see if we can get towards some sort of shared vision of what we should do with them, potentially throw out PRs to accommodate them, and then move forward. So Joe, if we could just start marching through these issues, that would be great. Right.
Sorry,
So,
Chris.
yeah.
Can
Go
I just check?
ahead.
I would like, if it's okay, to ask a question before we delve into those issues.
Yeah, go for it.
So I sent mail to the list. I didn't create issues in GitHub, but I have what I think are a couple of additional issues that are not on that list.
I mean, yeah, if we have time to talk about them at the end, we can. Ideally, all these issues are tracked in GitHub, so we can have the conversation there. But yeah, once we get through these, I'll turn it over to you if you want to just start marching through yours. I think we have what, like 45 minutes? I forget how much time for this.
So again, I mean, I think again, if possible, I think there's one of the, I think that would be fine for all except one of the issues I raised. And one of the issues I raised is that I think this is all just too complex and likely to get more complex. It might make sense to think about that first, if ever.
I think we're all under no illusion that this is a complicated thing to implement, and surely we're not trying to make the thing more complicated than it needs to be. I think we're all trying to be mindful of complexity as we propose resolutions to particular issues and resolve things like HRR and so on. The final slide for this particular section will be a proposal, or it talks about a proposal in helping to deal with complexity going forward. So I'll note it now, but I don't think there's much we can do other than say, we'll try to not make things more complex than they need to be, which I think is a sort of your design goal that we all have.
Okay, so I'd appreciate if you can leave a bit of time at the end for, I think all but that issue would be pretty quick. So if we could leave 5 minutes or so, that'd be great. Yep,
sounds good. Right, so the issue up on the screen right now, if you can scroll up a little bit, Joe, just so the title gives context for people. It's basically that right now there is a sort of obvious distinguisher for ECH versus non-ECH in that if you're using ECH, it prohibits you from attaching a PSK on the outer client hello for various reasons. See the draft and the various attacks that we encountered with sort of ticket oracles and whatnot. But if you're using Greece, you're allowed to send a resumption PSK, which means if you see a PSK, you're likely to determine that this is definitely not ECH, and therefore it sticks out. So I think there's a proposal down at the bottom in terms of addressing this. Can you scroll down, Joe? Oh. Right. So effectively what the proposal is to recommend or suggest that clients may or should, depending on how you strongly feel about this, send a dummy PSK if you're using ECH and you have an inner PSK as well. Because one of the interesting edge cases is wherein if you have a PSK in the inner client hello, and the server in its response after accepting ECH replies with a PSK extension, some middle boxes might interpret that as non-compliance, like there was no PSK extension in the client hello, but there is one in the outer client hello, or in the server hello rather. So trying to deal with that seems at least useful from a sort of deployability perspective. And that's probably the most we can do in terms of this particular issue. Anything more in trying to like hide the fact that you're doing ECH by like playing with dummy ECH or not, or with dummy PSKs or not, seems complicated. So I think the concrete proposal here is to just stick with stick a recommendation in text that says, if you have a PSK and you're using ECH, you may also additionally send a dummy one in the outer ECH. And the dummy one being like it's obvious, it's generated randomly, length TBD and so on, and we can bike shed on that later on. But that's the proposal. So I'm curious to hear what folks think about this. Okay, I guess if there are no objections, we'll just grab the PR to propose that and move that forward, and then we can discuss particulars in terms of like length of dummy PSK in the PR. Can we go to the next issue then? Right. So one of the changes in the editor's version right now, which will be included in draft 10, is basically a reversal of a change that landed long ago from a client-side computer config identifier based on the hash that was negotiated with ECH back to a server-chosen config identifier, which is now a variable length octet string. This issue is tracking the possibility or potential to make this connection identifier shorter. Length TBD. I think the current proposal in the text is a single byte, but there's been, also heard like 4 bytes, 8 bytes, or just like keeping it as is. And I think there are good arguments potentially to be made for both. So people who feel, I guess, strongly one way or the other about this issue, I very much like to hear what you think in terms of what we should do. Be it close it. Yeah. Ecker, go ahead.
Yeah, I mean, so I think I was the person who made both changes, the arbitrary one and then the shrinking it down to something else one. But I'm happy to have a fixed length thing, but I think a 1 byte is too short. And I just think this is one of these things where like people think it's like, people think it's like, oh, we're never going to need it, and then you're like really sorry later. So if you want to do like 4 octets, I'm fine, but like I'm like not cool with 1.
I mean, 4 octets would be fine for me, I guess. I'm just like there have been other. My primary objective here is basically convergence with other potential structures that have the same semantic information. That is like, here's all the HP key information that you might need. Oblivious HTTP is one particular proposal, which happens to use a single byte right now. But it'd be great if these things could share the same code, because there's no distinction between them beyond this particular length right now. So a 1 byte is fine for me. 4 bytes would be fine as well. I think Martin pointed out, unfortunately he's not here, that in a proposal to actually land this change, that getting consensus on this is going to be quite challenging. So I feel like not everyone's going to feel strongly about this. So this is somewhat of a bike shed. All that said, I'd be happy compromising with 4. Does anyone else feel strongly? Ben, or Ecker, are you still in the queue? Okay, yeah, Ben, go ahead.
Hi. Yeah, so variable length it concerns me because the variable length itself becomes another piece of implementation leakage that tells you information that we don't. It creates divergence between implementations and creates more leakage about exactly how the client and server are implemented, as different implementations choose different lengths. And also it invites injection of arbitrary information there that could be used in all sorts of strange ways. And it's all in clear text on the wire, right? So like creating more clear text is not really in line with, I think, the goals of TLS. So a fixed length is preferable to me. I would appreciate a reference to the HPKE key identifier that you're talking about.
You mean the oblivious HTTP one?
No, I mean you were talking about some kind of key of. You were saying that in some other HPKE context there's a 1-byte identifier. I guess I was trying to figure out what you're referring to.
That was oblivious HTTP. I will pull up a reference.
Oh,
right now.
okay, thanks. So yeah, I guess then I would be interested to know whether there are some sort of different design considerations that would mean that that context couldn't also use some other length. I do think we need to understand what it is that we're talking about here, right? To me, the fundamental discussion we are having here is trial decryption required for servers? Are servers required to implement trial decryption, and we're trying to make sure that they actually do that? Or are we trying to say that trial decryption is not required?
So, I mean, I don't see. If we go for 1 byte or 4 bytes, a server is going to have to support trial decryption nonetheless, most likely. And I find it, I'm not seeing right now how we could get around potentially having like just that code path in the stack.
So at 4 bytes, I think trial decryption essentially is no longer required, basically. You know, as a server operator can reasonably expect to be able to assign every key present in the fleet a unique ID, which means they don't need trial decryption anymore.
And you could make the same argument for a single byte.
Maybe, but I interpreted the use of a single byte partly as an attempt to say, you know, we're not going to let you escape from trial decryption.
Oh no, I mean the primary motivation was we don't want more bits for tracking. It wasn't so much about trial decryption, but
okay. So yeah, I mean, as my overriding concern really is about the impact on Greece, because with 1 byte, it's not easy to tell the difference between, say, sequential allocation of keys and randomly identified keys. But with 4 bytes, it becomes pretty trivial to look at this and say, well, you know, this server normally allocates its keys starting at 1 and go, you know, walking upwards, and your key is a random 4-byte integer. So that doesn't look like real.
I would agree. Although it's not clear to me that that's a design constraint we're trying to operate under. That is specifically making it so that someone who's looking can't distinguish this from Greece or non-Greece for the purposes of doing nefarious things, not potentially it being an interop or a deployment issue or whatever. So yes, it's possible to, you know, choose your config identifiers and update them, rotate them, whatever, in a dumb way such that they stick out. But also know that like it's probably also possible to see when a client is reusing a config identifier, regardless of how the server chooses it. Like, so for example, if the client happens to connect to the same server back to back, it's going to use the same config identifier, whether or not it's like it looks like a random byte or looks like a random 4 bytes or whatever. Whereas if it was using Greece, each time that would be in theory different because it's randomly chosen, assuming that's actually how you would spell it. I'm not sure how.
To be more concrete, I think that there are things we could do here that would help. Like, for example, a 4 or 8 byte ID that comes with an instruction that says thou shalt generate this randomly when constructing your ECH config, I think would be better. for Greece on the client side, I think an instruction to Greece that says, maybe try to make this consistent over subsequent connections could be useful.
The current proposal does suggest text that language. So it's not just like you use a counter, it's like you do rejection sampling when choosing a config identifier, specifically for the reason that you say, although we can't like require servers to do that. Just ask them to do it nicely. And there's probably something you can do on the client side as well that says, yeah, be smart about how you are, choosing your config IDs if you're greasing, if this is something you're concerned about. But like specifying that very clearly seems quite difficult to do. So it's not clear to me, especially given what it reveals, that it's worth biting off, but maybe it is. Carrick's in the queue.
So hopefully people can hear me. It seems to me like, because of the tracking vector, you have to decide like where that's no longer an issue. And it seems to me like 4 bytes would be an issue. So if 1 is too little because, it's just not big enough, you might need more, then why not 2? I mean, I don't know how you can quantify like at what point it's no longer a concern, but I don't know. It seems like jumping to 4 is just way too much.
My response to that would be what basically is what Ecker has pointed out, and that the tracking argument is not great, in particular because we kind of already assume that the adversary controls DNS, and if it wanted to track, it could just like vend out unique IP addresses to tag specific clients that way. So I don't know. I don't feel strongly about this one way or the other. I would like a resolution.
Okay, I didn't see an argument saying that the attacker has to control DNS in this context or in this situation. Where's that?
Just the default sort of threat model for ECH, that the attacker controls DNS. Huh. It's one of the appendices in the doc.
Okay.
Ecker?
Yeah, okay. I think I'm somewhat persuaded by Ben's argument, but I think I'm mostly persuaded that like the consensus is largely that like we should have 1 byte. So while I think we're going to be sorry later, I'm willing to go with it.
Does anyone else want to chime in before we note that and move on? Eric?
And as a I guess the alternative would be to keep it at variable length, but have a recommendation that you should do 1 byte. Or is the concern there that an attacker controlling DNS could inject stuff that they then observe the client using? Because a malicious server operator has a bunch of other ways they could do things, or could just not enable ECH.
I think that's the crux of. I mean, I don't want to speak for Ecker, but I think that's I interpreted that to be the crux of his point. And so, if shortening the config identifier yields no concrete benefit, then perhaps not do it at all and allow servers to be flexible. But it does sound like more people were in favor of shorter than longer. Unless there's like any other concrete objections to that, I'll just mark that and move on, and then we can potentially discuss it in the PR. Yeah, David?
One minor thing on the variable length stuff is that it does give a pretty large vector for the DNS to inject arbitrary contents into the bytes that the client sends over the wire, which is not like this is the only source of this sort of thing, but occasionally we've had issues with confusing a target server with expecting another protocol or weird stuff like that.
Eric, did you have more to say, or are you all set?
Oh, you mean other Eric?
Oh yeah, sorry. It might be worth doing a hum. Yeah. Just to firmly sort of make it concrete. Joe or Sean, would you mind kicking one off? I think the hum. We don't have virtual hum tool this time. Okay, Joe or Sean, do you know how to use show of hands?
I did at one point, but is it still there? They move it.
I see it.
Up to the right. The bar graph thing across the top.
Oh, okay. All right. So what is the decision point here? Is
Are you in
fixed
favor
length?
of a 1-byte config identifier?
Okay. Favor of 1 byte. Okay. Okay. So the first question will be, are you in favor of a 1 byte? And the second one question will be, is are you not in favor of a 1 byte? Okay, so I am going to start that now. All right, it looks like the numbers are starting. I'll give it a couple more seconds here so people can find the function. All right, so we have most people in favor. Well, we have 21 in favor and 16 did not raise hand. I'm not sure how to interpret that. I think we're going to do, should we do another question?
I think so. Just negate it.
Okay. Okay, now this is not in favor of 1 byte. I'm going to start the session now. Okay, I think we're stabilizing on our results now. So it looks like to me for not in favor of 1 byte, we had 10. In favor of 1 byte, we had 21. So there's a pretty strong leaning towards the 1 byte. But there are still some folks who are uncomfortable with that.
It's not surprising. This is sort of an epic bike shed in a way.
Yeah.
I will note the results of the poll and the issue, and I will draft a PR accordingly.
Okay. Do we want to move on to
Thanks.
the next one?
Yes, please.
Okay, I think I have let me know if this is what you expect.
Yes, sorry. So I filed this issue a while back. This is sort of also a bike chat, but given we're trying to reduce complexity of things, there is the way we're using HPKey right now, the config identifier is currently wrapping the public keys that we get in configs with basically a length prefix. HPKey was specifically designed such that that is not necessary, although the encoded public keys have a fixed length. So this proposal is to basically make fixed length fields fixed length. Currently it only applies to config, or the proposal is only config contents, but if you scroll down a little bit, Joe, the similar encapsulated key that is carried inside the client hello extension is also in practice fixed length, but making this fixed length could complicate trial decryption. So I'm not sure where people feel about this. I'm perfectly happy to close it, but just noting this as a potential optimization that we might do. David, go ahead.
I don't feel very strongly about this either way, but I think one thing we should probably keep in mind is that if we do fixed length, then if you don't know if you see an unrecognized chem ID, you aren't able to parse the message anymore. So I think it's fine in that, like, for an ecconfig context, if you don't recognize the chem ID, you may as well drop it on the floor, and likewise with the client ECH structure. But this would be introducing a new place for this, whereas previously we said that, well, if you don't understand the version, you can drop it on the floor, but everything else you can at least expect to parse it. I don't know if we said it, but it is currently the case. You can expect to parse it.
That was the thinking for the config contents, where if you don't recognize the ID, you just skip the rest of the thing. So yeah, that is the trade-off. You must know you must understand the corresponding chem in order to actually parse the field. Watson?
Watson Lad Cloudflare. I can't remember, but I thought there's something where you don't necessarily have a length for a struct if you just if all the fields are fixed, but maybe that's not the case. And I worry that when you have this thing where you need to look inside to see the length of the whole thing, that might be a problem for the TLS wrapping, but I can't quite remember.
Not sure, but maybe Ecker knows.
Yeah, I mean, I think this one is actually okay in that respect, because if I'm reading this language correctly, the ECH config has exactly one HPKey config, and the ECH config itself has a length version, so you can skip past the ECH config. Well, I'm sort of like bleh on this either way. I mean, I think I understand why people want to do it, but it's honestly actually harder to it's actually for the parser, for a lot of parsers, it's actually harder to do it this way because it means that you can't have like a generic parser for the structure, but rather you have to call out to the chem table. So I understand why one would think it increases simplicity, but I think it actually decreases modularity at a cost of notional simplicity. So I think I'm generally against this, but not willing to let it on the road.
Yeah, in terms of a time check too, we got about 10 more minutes before we got to move on to the next presentation. So as usual, this sucking up the air out of the room.
Thanks, Sean. Yeah, I'm perfectly fine with that. Why don't we just close this and move on then? In implementing this elsewhere, that chem table dependency was kind of annoying. So if folks want to use general purpose parsers to parse these configs, that's reasonable. So I'll note this and close the issue. Right. So, David, I don't want to speak for you, but we filed this issue to just sort of, now we're using it to track all sorts of interesting DOS vectors and processing client hellos and outer extensions and whatnot. We did land some text to address one of the particular mitigations and that mistakenly closed the issue, but reopened it back up. I guess the question for the group here is to what extent do we want to either, and maybe this sort of carries over into Stephen's point, to what extent do we want to note that these potential DOS vectors exist versus like modify how the compression mechanism thing works entirely to avoid them altogether. So the queue's long, so I'll just turn it over to the queue.
Yes, I think we reopened it in part because there was a second DOS vector that we forgot to document. But yeah, the current decompression thing is a little bit fussy. It is possible to implement it without problems, but I think we should probably like my feeling is that if we can come up with a simpler thing that still meets our goals, then we should switch to that. But until we do that, we should go and document the couple of tricky points. And I think we documented one of them, and then we realized there was a second one. So hopefully we can go document that too.
That's my impression as well. Stephen?
Yeah, I mean, I guess there's, in addition to what was said, I think this also creates quite a testing burden if it's done as anywhere near as is with that kind of level of generality. I don't really see a huge benefit or any benefit, to be honest. And I think that there's no sensible way to choose these things. And it's going to make it impossible to ever do or to ever know you have something that's going to be fixed a constant time around near it. And I think the only real use of this is if there's PQ chems that have very large keys that we don't have yet that we could figure out later. So I honestly think we'd be better off just dropping this entire thing.
That's just dropping the outer extension compression mechanism entirely.
Yep.
Great. I mean, yeah, it's a reasonable proposal. I think we should just, it might be worth it to see where people stand on that.
I mean, I'm sorry, I wasn't suggesting a home right now. I think that might be better to see if the suggestion to simplify lands somewhere better. I don't think it will, but I think at that point it might make sense to say keep it or drop it.
Thanks. Kara, go ahead.
If you want to discuss this now, but just it doesn't seem necessary to me to just throw out the outer extensions thing completely. That's it.
Thanks. Yeah, given the interest of time, I suggest we just take this to the list. Stephen, would you mind just spinning up like a new thread specifically for this issue on proposing dropping this, just so we can track that outside of the longer thread that you have?
Yeah, sure.
Excellent, thanks. All right. So I guess then for this particular issue, while we sort out whether or not this thing should exist at all, we can just make sure we note the other vectors that exist, and then close this one accordingly. Okay. So the last one, not for review, just pinning it here for people to look at. This is the Whopper, the HRR issue. We don't yet have a PR up for review, but if you go forward to the next slide, what I would like to do is start meeting a bit more regularly with regular interims, specifically for ECH between now and 111, with the primarily with the sole purpose of resolving the HR issue and getting sort of the spec quote feature complete, and then potentially trying to get rid of any unnecessary complexity if we have it. So I don't have I guess a preference in terms of cadence. Biweekly seems pretty reasonable to me. Every other week, that is. So what I would recommend or propose we do is just send out a doodle poll to arrange a time for this meeting to take place, and then people who are available and interested can jump in, and we can drive these issues into the ground. What do you folks think? Great. Steve? Stephen.
I mean, I think it's the only way we're going to get this done. So I think it is what it is.
Sounds good. So let's set out the doodle poll then to get that going, and then we can hopefully kick off the first meeting shortly thereafter. How much time do we have left, by the way?
5-ish minutes.
Okay, Stephen, then I'll just turn it over to you if you want to talk about the issues.
Great, thanks for taking the time. So I put in the chat room. I put in a link to the mail I'd sent to the list, and I think the best thing to do with the time available is just go through them in kind of reverse order from the second last one, because those are kind of quickest towards longest, and hopefully we might get some of the quickest. So the quickest one is the current text requires the outer SNI to be the public name and has a must. And I don't think that's a good idea, because I have other use cases for command line tools where I want to do something else, and it doesn't seem necessary. So I raised this a couple of times, and I don't believe it's gotten discussion. So if you're scrolling down to the bottom of that mail, it's
in the queue
for Joe. Ben?
So I don't have to tell you, but the must is there to support the fallback mechanism, and without that name in the SNI, the fallback mechanism doesn't work. I think it's totally reasonable to imagine there might be sort of specialty use cases where you don't need the fallback, and therefore you aren't subject to this requirement. So I think we can probably come up with a phrasing for that. I view this similarly to the TLS 1.3. Yeah, SNI must. Like similarly, TLS 1.3 says you must include the SNI, but actually there are cases where it doesn't make sense, so you just don't do it.
David?
This is a quick clarification. Are you talking about the client's must level requirement to include the public name, or a server requirement to check the public name? Because it sounded like you were talking about the client, which does have a must, but the server, I don't think there is such a requirement right now.
I'd have to open this back again to look, but I just think the restriction isn't needed, and I don't plan on implementing it on the client or the server.
Because the reason that I think I was confused on your email thread, because the email seems to read like it's the server side.
Thanks to Ben for reminding us why the must is there. I don't see any way to get around having the must there if you want interoperability for the client to send it. If Stephen wants to suggest some language that would like cut out for people who have reasons not to do it, I suppose one can imagine doing that, as long as it clearly says what the consequences are. Sounds like nobody thinks we need the must check. And people may even think it's not there, so perhaps if it's there, someone could, if Stephen, if you think it's there, perhaps you could file a PR to remove it. Yeah. Also, I guess I'm not particularly moved by you don't plan to implement it. You could feel free to be non-conformant.
But hence raising it, I think it's better if it was conformant.
Sure, but I think I understand, but there are reasons for it to be there.
In the interest of time, Stephen, I just did a quick look through the doc, and I can't find it on the server side. I can't find the server side must. So what I recommend is just to file an issue pointing to the text that you think is problematic, and then we discuss it there. If that's okay?
Sure.
Okay. Just to give you time for the other.
I think the other topic that's maybe worth just spending a minute on while we have everybody is this is just too complex, and I'd love to get us to agree that our goal is to make it simpler, because in what I've seen from the GitHub discussion, it tends towards more complexity and no apparent focus on trying to make it simpler. That may be just perception. I
mean, I can't speak for everyone else, but in working on this, it's been a distinct design goal to not make this thing more complex than it needs to be. So I don't know to say much more beyond that. I think that's true of all the work we do in the IETF.
I guess I'm the only person in the queue. Yes, I also think it should be simpler, and I'm interested in concrete proposals to make it simpler. Like, certainly we did attempt to do so, and I recognize that things got more complicated. I think in some respects the use of ECH rather than ESNI was an attempt to roll up a bunch of pieces of complexity which are kind of crept in to make ESNI work that weren't needed with ECH. But I think that the highest priority is that it work and do what it's supposed to do. So I'll be interested in proposals that make it simpler and consistent with it continuing to work.
Yeah, so I mean, I think if, again, given time, we're kind of out of time, but if these interim meetings have a focus on trying to keep it simple or make it simpler, that I think would be good. And I think it's too easy to, with HRR particularly, to try and end up with something that's more complex, I think.
Agreed. Do you want to talk about any other issues in your list?
I guess if we're going to have interim meetings, we can. I'll try and get those onto those agendas rather than. Well, I don't think there's other ones that will benefit from lots of people that we have in the room here and consume everybody's time. So, interim meetings.
Thanks. Please file issues for these so we can track the discussion there.
Please track the discussion on the mailing list as well. But we don't need to talk about that. That's been in the chat room already.
Okay, so I think, are we wrapping up ECH now?
We'll send out a Jabber, or sorry, not Jabber, definitely not Jabber, a Doodle poll so we can schedule the first interim meeting and go from there.
Cool, that sounds good. All right, then moving on to RC 8446 bits. Ecker, you are up.
I can't figure out how to tell which camera it wants, so I guess we will not have video. Okay. Right. As people know, 8446 bits is just a minor revision to 8446, focused on cleaning up some ambiguity and also turning towards more inclusive language. Next slide. So I think I'll get the I'll get to the end of this first. So hopefully we can close these issues and any other editorial ambiguity type stuff. Then issue some kind of call for remaining issues to make sure we capture them all, because I don't want to do 8446 bis. And then I'll issue a new draft and maybe even do a working class call. I do think we probably should do a final call for remaining issues before we do working class calls, because I'm sure we'll flesh out a few. Next slide. The first issue is issue 1214. For those of you following along at home, this is about recommended versus not recommended. So as people may recall, when we initially designed the registry scheme that we have for 1.3 with the new registry documents, what we were trying to do was deal with the fact that a lot of people wanted to register cipher suites that we didn't want to review. And that might be bad or it might be good, and we didn't want to have the TLS working group have to spend a lot of time, or the experts, reviewing the code points for quality. So what we did was we basically opened the registries way up, but then had a thing where we had recommended in a non-recommended column. And recommended basically meant A, this is standards track, and B, we think it's a good idea, and not recommended meant anything other than those. And what we're finding is that actually doesn't work as well as we were hoping in a specific respect, which is two specific respects. One is that the things we actively want to disrecommend, that we still want to let people register, because we don't think that having code point registration as a gateway to not doing things we don't like is a good idea. And the second is there's sometimes when those recommendations or non-recommendations need to be nuanced. So for instance, I think people are comfortable with Ben, yeah, I thought that already. Yes, Ben, that should happen. I think it already did, but maybe I just forgot to write it down. And also there are cases like as with CCM8 where maybe it's okay in some circumstances but not in others. So my proposal is to have 4 categories, not 2. There's recommended, which is what it currently means. Conditionally recommended is the same as recommended, except that it's good for only some limited scope. So like the TL, ASGCM 246 would be continually recommended, for instance. And so like CCM8 maybe would be conditionally recommended, that we say it's not good for generally for like the web, but if the IoT and I'm moving a lot of data around, then it's conditionally recommended. And you have to explain in that what that meant. DKG asked how it's supposed to be annotated. I was hoping we'd have a column in the IANA registry. The not recommended would mean what it currently means, and we have no opinion on this. And discouraged would mean I think it's actively bad, and like you shouldn't do it. But we're just letting the company register. An example of that would be these authentication only set for suites, which don't currently meet the TLS security guarantees. My proposal would be, so obviously recommended, condition recommended, continue to require working group support, but that we'd allow the experts to decide between not recommended and discouraged, and allow them to put the external registry, the external, sorry, I'm reading DKG's comments as well, and I'm getting confused. We'd allow them to indicate what the reason why something was discouraged was. I think there's some question about exactly what IANA would be willing to put in these columns, and what, and I'm not quite sure about that, but I'm sure we could sort that out with IANA. I'm also happy, by the way, people seem to be not thrilled about recommended, perhaps, and maybe want to change not recommended to mean something else, so I'm not quite sure what that would mean. No opinion, maybe. Anyway, but I think these 4 levels are probably the right 4 levels. So maybe people can give us opinions of whether those 4 levels are right, and then we can discuss the names we use for them. A couple points here that I see people raising in the chat. If you want to raise them verbally, or shall I just respond to them in the chat in real time?
This is DKG. In the chat, people are proposing no opinion. I think that's a mistake. This working group has at least as many opinions as it has speakers. Maybe even as many or more as it has participants. And often, we're going to stalemate on some of these discussions and land back in that spot. Saying no opinion makes it sound like whatever, you can use it if you want to. And I think we do want to really make sure that recommended retains the pride of place of saying this is fully endorsed by the working group. So no endorsement, maybe?
I'd be fine with that.
If I jump in next, then okay. Is discouraged strong enough a word for something that to read from your slide is known not to provide the rated TLS 1.3 security guarantees?
I'm open to it. I just picked that word more or less out of the air. I'm totally open to some other word. I just don't have one.
Okay, but maybe something to put in the list afterwards then.
I don't know if I'm running the queue or you are, chairs. Daniel?
Can you hear me?
Yes.
Okay. So, 2 things. The first thing is I see that the recommended term might be misleading, so it might be good to rethink that term. I have no, I don't have any proposals for that. And the second one, if we had different categories, I think I agree with DKG saying that it might put the working group into a position that is going to put a judgment on any extension or cipher suits which might be difficult. So I'm questioning how it's feasible. So that's my comment.
Well, we already have, for anything we recommended in it, we already have to make a judgment because it has to be standards track. And so I guess I figure once we're bothering to make a standards track judgment, we can probably decide whether applicability as well.
So to just jump in real quick as AD, the IANA experts have to be involved in like any code point allocation. And so what we would be doing here is to be writing rules about like which code points the experts can approve for what, and if there's like some state transition that we would have to come to the working group and do that. But I think we need to be able to write something that the IANA experts can just do their thing, and we don't have to put the working group in the critical path for every allocation.
But I thought that the IANA experts were not involved in the working group allocating the code point.
Yeah, I mean, I'm coming at this from the lines of things that are going to get like discouraged on them.
Right. Right. My proposal was we would give the experts some guidance. We would trust them, and if people didn't like discouraged, they could complain to the working group, and then we could take it on. Rich.
So, yeah, as one of the experts or designated, I think the above the line and below the line in terms of working group and non-working group involvement makes a lot of sense. I know that generally we have deferred to CFRG when we were looking for algorithms, so presumably the working group would also want to still do that. And I'm guessing that where it says at the bottom, known to not provide the rated TLS 1.3 security, when TLS 2.0 or 2012, whatever you call the next version, comes out, it would include a big section which would move around a whole bunch of ciphers. Is that your expectation?
I mean, I would sort of hope not, just because I hope that like 2.0 will feel enough like 1.3 don't have to worry about it, but that could happen, yeah.
Well, yeah, right, quantum computers, right?
Yeah.
No.
I think obviously being quantum computers will have to do with all the stuff.
Yeah. Okay. Thanks.
Sean, you're up. Sean? Maybe Robin's up.
Hi, is the audio working?
Yes.
Okay. Yeah, just a really quick thought and probably a naive one. But I mean, we have RFC 2119, and that sets out may and should. Are we just trying to reinvent that here? And how do other specifications that include may and should qualify the options within those terms? I mean, we must have run into this before in other specs.
Yeah, I feel like this is a somewhat different case, but certainly.
Hey, am I back? Yeah, so no chair hat on. So I guess I had a question. So this doesn't actually apply to 8446, right? Because 8447 is the one that defined this category. So I'm not sure if this should actually go.
Oh, wow.
I'm not sure this should even go.
Amazing. Yeah, this is amazing. This is not my problem.
So I think it's not your problem, but I think the problem you've identified is an actual problem, because we've had this problem where basically like the discouraged use case now, people are claiming that like the TLS working group is uninviting and not helpful and, you know, closed cabal, etc. So we have to figure out some way to be able to signify these things that you can run this protocol in any way you see fit, right? Some are more secure than others, and this is just one way for us to kind of put a slant on it. I don't have any problem with trying to come up with 4 categories and naming them or numbering them or giving them colors or something. But we have to come up with some better way for things to be categorized essentially.
You're up, Farrell.
Yeah, I put this in the chat, but just there's a bunch of other people copying this scheme. If we make it more complicated, we better be able to explain it so that it won't be confused, even if people want to confuse themselves deliberately. So yes, if this turns out to be Sean's problem, then it might be tricky.
Okay, well, I think we come to the conclusion that we can just skip past this issue and like Sean will have to solve this problem with a new 8447 BIS. Get on it, Sean. Okay, next issue, 1212. So it's proposed that we have a sort of general alert, which basically means something went wrong. People sometimes think internal error works for that, but that's not what internal error is for. Internal error is for like, I am screwed up, as opposed to you sent me something I don't like. And the idea was that you could just like always admit like error instead of having to admit the specific error. There was also some opposition to this from some people. But my proposal is that we define something at the main level and say you should say something more specific if you can, which has the unique benefit of splitting the difference between everybody. I'd also be fine with just closing this without change. Anybody want to weigh in on this in any way?
Yeah, Ben Kadek, no hats. I mean, I think in general, there is some value to allowing implementations to be as black box as they can and just always emit the single error or no error signal. So I think there's probably enough use case here to put in the general alert.
Carrick?
Carrick, yeah.
Encouraging as much specificity is good. I think allowing a way to not be specific is not good, but if people really, I don't really see why someone would need that, but so I would just say, yeah, encourage as much specificity as possible.
Hearing no other real objections, maybe someone could note this in the issue. And next slide. Okay, so the current text around user canceled is pretty confusing. And actually, I know David Benjamin's here, so I'm really hoping he can help shed light on this. I know people send user canceled, and so you shouldn't be treating it as a fatal alert. I think the text doesn't quite say that. It seems that there are two options here on the other side. One is to ignore it, and the other is to treat it as if, and just like pretend it wasn't sent, and to treat it as an alias for close notify. Like as in it's a, this is, and so what we know is some implementations send user canceled and then close notify. David, what I don't know is, do ever send user canceled and then a bunch of crap and then close notify, or they just send them in strict succession? Because if it's the latter, then probably you could just like always treat it as if it was a close notify. So I'm hoping David Benjamin can help us out here.
I don't believe they send anything in between the two alerts. But I might still suggest doing ignoring because if you like one of the use cases, I've never seen a protocol that does this, but close notify is supposed to signal that like nothing comes after this, but something does actually come after it. And so if you like stop speaking TLS, but then reuse the transport for something else, which I think close notify was supposed to support, then you might be a little bit sad if we like terminate it slightly early. Ignoring it also matches what I think every implementation that I know of does.
Right. So as I understand it, I see. And user cancel does mean, as I recall, like the handshake they failed, and we're not gonna complete the handshake for you.
Yeah, the implementations that are sending user canceled are like entirely violating the spec. They're sending it after the handshake fails as a like
Right. Okay.
This came about because we got rid of we made shutdown unidirectional rather than bidirectional to match TCP, and they're using this as a like funny signal to the same implementation on the other side that like, oh, I want you to do the old behavior.
I think ignore it's fine. Can someone unless someone objects, can someone note that in the issue? Next slide. Okay. So actually, I think we're basically done with this. There's some question out there whether unsolicited extensions text is clear enough for extensions that like are just indications that don't have responses. But I think we had a bunch of discussion in the GitHub issue, and as far as I can tell, Jonathan does not think that we actually need to leave this open. Merely the text wasn't clear, so I submitted a PR to make the text clear. So unless somebody objects, I'm just going to merge that PR. And what the PR says is PR basically removes this, like basically said, like stops calling this indications, and it's just like they're like requests, and they're requests and responses, and so they follow the same rules of the requests. Hearing no objection. Next slide. Is there a next slide? Right. Wow, that was amazing. Nice work on the slide deck here, Ecker. Right. So there's still not much left. Yeah, chairs. I think sounds like we basically have closure on every outstanding issue. There are a few editorial type issues that are like floating around that like I need to fix, but I think they're all clear. I think can you guys do a call for other remaining issues, like a couple weeks or something, and then and I'll get this cleared out.
So I guess my only question about the remaining issues is the HRR issue that came up with respect to ECH. Is that going to be addressed here or elsewhere?
I'm not sure I understand it well enough. I'm not sure I understand what you're referring to well enough.
Because I thought there was. I thought that there was an HRR issue that came up with that David Benjamin brought up. Where there was some conflict in the text, and it may have gotten.
We have David Benjamin, so it's convenient.
No, good. There we go. I'll be quiet. Thanks.
So it's not so much a conflict in the text. It's the if you don't say an extension in HRR, then the client is obligated to send it as is, which is kind of annoying and probably was the wrong decision. At least the current thinking for ECK, or amongst some of us, is like not been confirmed or anything, would avoid this issue. I do think it seemed like from the last meeting that we generally believed the current text was a mistake. I don't feel strongly about whether we fix this here or not. Either way, we need to like go and test the implementations that implement the check more strictly.
I'm not sure I understand this well. We've already discussed it now. Do you mind filing a specific issue on this spec so that we can talk about it?
Yeah, that's a good idea. I'll do that.
Daniel?
Yeah, I'm just wondering, I remember we raised a few errata at some time, and I'm wondering if those errata have been part of these minor issues.
Yes, I went through every erratum and either filed issues for all of them, and then either addressed them or declined to address them. You can find that in the GitHub in the GitHub errata, GitHub issue list. So if you disagree with my treatment as one of the you should be able to figure this out. But if you disagree with my treatment of the errata, please flag it to me.
Okay, well, I don't remember what I raised, so that was my.
Well, there's like 30 of them, so like you could just go through. Like I said, I did clear these with the chairs, so or at least with Chris, because we were working on together. So I think there was like no one was like thought it was really wrong. Anything that was at all controversial, I tried to jack up to a real issue that people would discuss.
Okay, thanks.
Hi, this is Ben again. I guess I have 2 points now. One in response to the errata question. So most of the errata are still in the state reported. And so I think when the document gets sent to me for publication requested, ideally we can also get a list of the errata and their dispositions at the same time, so I can go and process them in our RC editor system. And then the second point that I want to raise, which is actually what I got in the queue for, is that currently in the data tracker, we do not list a intended RFC status for this document. And I think there is some question about should it be proposed standard or should it go for internet standard? And I think we should have an answer to that question before working group last call.
For my part, I do not care very much as long as I don't have to do as long as I don't have to do very much. So if I have to do work, then I definitely am in favor of post standard. If I don't have to do work, whatever.
Yeah, I mean, I don't know that we really have to write an implementation report given how many people have implemented this stuff.
So I think we can do two things. One, we can point to the interoperability matrix in the interoperability report. That the interoperability report is required. We can point to the interop matrix.
No, it's not required anymore.
Oh, but I mean, I thought you had to write something, and you could pick your pain level, and that's what I'm saying. Is like, hey, we did all this interop. It's over here. Thanks.
Sure.
All right. Well, I'm gonna leave this. I think to the given that it sounds like the chairs have hit the work and I do not. I'm gonna leave this to other people. Yeah. So I'm happy to produce a report though about the errata, about how we handled each of them. I can probably like force GitHub into producing some kind of document which I can like set up, do some set work on. I'm actually, I mean, if I don't think I'm allowed to actually do the errata myself, if you want. So I think you're going to have to do it yourself. But if someone wants to give me the keys, I'm happy to also solve them.
Yeah, I think I have to do it myself. And I somehow thought that there had been some preliminary version of this report that went by at some point, like months ago. But thank you for offering to put that together. I think that's
Yeah,
it for me.
it might be in an email. I'll see if I can find.
Sure. Thanks.
I think I'm done. Bye-bye.
All right then. I think next we have deprecating FFDH. Tarek, I think.
Yeah. Hi. So I'm Carrick. I don't know, probably most of you don't know me, but together with Nimrata and Filippo, I'd like to propose a draft that deprecates non-ephemeral finite field Diffie-Hellman cipher suites and also discourages the reuse of ephemeral FFDH cipher suites. So last September, if you can go to the next slide. Here we go. So last September, some security researchers disclosed an attack that they called the Raccoon attack on TLS connections that use static finite field Diffie-Hellman cipher suites and also finite field Diffie-Hellman cipher suites if the public key is reused. And it's a timing attack, and it basically uses the server as an oracle to figure out the pre-master secret. You can go to the next slide. So we'd like to deprecate these and discourage the reuse of ephemeral keys. You can go to the next slide again. So these already aren't recommended since they don't provide forward secrecy. So really we'd just be, I guess, prohibiting them to the extent that we can discourage use, and they're already not recommended. Okay, next slide. So ECDH is not vulnerable to the Raccoon attack, but they are vulnerable to other side channel attacks, including the invalid curve attacks. So most attacks of this type exploit the fact that the server reuses a public key and don't work when the keys are fully ephemeral. So we'd like to take this opportunity to discourage the use of non-ephemeral ECDH cipher suites and prohibit the reuse of ephemeral ECDH keys. Next slide, please. And these already aren't recommended too, because they don't provide forward secrecy. Next slide. So in summary, deprecate FFDH, prohibit, forbid the reuse of FFDHE and EC, that's a mistypo there, DHE keys, and then also discourage ECDH. That's it. Any questions? I guess I don't know if the chair. Do the chairs lead the questioning part? Or should I just call out people?
It's fine if you just call out people.
Okay, Renee, go ahead.
Hello. I just have a question. Isn't this raccoon attack essentially an attack against variable size representations of the shared key? Because it seems that you're confusing the attack with the cause of the attack. I think it's due to the representation issues and not due to ephemeral or reuse of ephemeral keys.
I'm not totally sure what you mean. I mean, the attack is possible only if you reuse these keys. So
yeah, but basically you rule out a very large class of protocols, whereas the attack is really caused by the timing attack is due to the input of the hash function being of variable size, right?
it's due to stripping the leading zeros, and that's in the spec. But it only
so what I'm kind of objecting against is that you rule out. I think it's an important mechanism to be able, at least in some cases, to reuse some ephemeral key material. You rule it out because of essentially an implementation, a specification flaw in old versions of TLS, where keys are not represented in a fixed way.
It's only in TLS 1.2 and below, but I mean, yeah, I mean, basically, so the alternative would be to actually change the spec, and that just doesn't seem really realistic. And these cipher suites aren't recommended anyway, so it doesn't seem like a good idea to change the spec instead.
Well, I can see, for example, all these encrypted client hellos and so on, they all use one-sided LGML. They would all be not recommended by your suggestion.
Sorry, I'm not sure I caught that. That what wouldn't be recommended?
So if you do a protocol where you have a client talking with a server with a fixed public key, and you have various clients doing this handshake. If this is a one-pass protocol, then you could arguably do this raccoon attack anyway, if there's a non-fixed representation of the shared keys. So I think you should fix the problem and not come up with some kind of bogus recommendation that is much wider than fixing the problem.
So if I can jump in, Renee, it sounds like you are wanting to get clarification as to the thing being banned is specifically like the TLS key exchange part, as opposed to other ways in which you might use Diffie-Hellman exchange in different aspects of the protocol.
Sorry, I didn't catch. What were you saying?
So there's the actual like TLS key exchange in the handshake, and that's problematic because the stripping of the leading zeros is in the protocol spec. And so the question that I think is what you're asking is, should we just be prohibiting that particular flawed usage of Diffie-Hellman, or should we be applying these prohibitions to all places where we might use Diffie-Hellman in the TLS context, regardless of the handshake key exchange versus other, encrypted client hello sorts of usage?
I think we should fix the cause of the problem, which is the representation issue, and we should not rule out.
We can't change the existing spec. We have to work within the constraints of the implementations that are already written.
Yes, but as I understand it from this presentation, the proposers want to rule out the reuse of an ephemeral key by the use of one-sided ECDH. I've just scratched the raccoon attack here on a piece of paper, and I commented on it in the kernel review of the last call of the catch suite last week. And this is definitely ruling out a very large class of applications of the Diffie-Hellman scheme without a reason, without solid reason.
Well, maybe we should take that debate to the list. And Ecker, do you want to go next?
Yeah, I mean, so taking a step back, you know, in general, like long-term Diffie-Hellman keys are like harder to use, right? You know, the raccoon is just a specific class of a specific instance of a general class of Oracle type attacks on them. Nevertheless, you know, we do. And then, of course, they don't offer PFS in many scenarios, though not every scenario. For instance, OPTLS does offer, you know, does offer PFS because it has a second Diffie-Hellman exchange. You know, in general, some care has to be taken to you when you're using any kind of long-term Diffie-Hellman key. With that said, I think as Renee's pointing out, we're not going to get away from like having long-term Diffie-Hellman keys being used for encryption because we just have too many things that need them, a la HPKA or semi-static Diffie-Hellman TLS. So we will have to face that at some point. I think that the finite field part of this, I think, is good, and I think we should definitely do it. I also think that the forbidding the static Diffie-Hellman, Diffie-Hellman is also good. I think that I'm a little more iffy on the prohibiting reuse of ECDHE keys. For two reasons. One, I know there are stacks which already do this, and so you won't be able to check it on the client. And also just generally, so I think, you know, this maybe should be a shift level restriction rather than a must level restriction.
Yeah, that's interesting, because to me the definition of ephemeral is like you only use it once, so it's odd to me not to prohibit the reuse of them, but. This
terminological question turns out to be quite fraught, as I recall. I'm just telling you there are stacks before you use them.
Okay. Watson, go ahead.
So I'm looking at the draft, and all it does is prohibit a certain name class of cipher suites. And if we were to fix the cipher suites, we would have to introduce new numbers, because otherwise we have an interoperability issue. So I think that we don't have that. There's no way to get around this. We have to ban these. With regards to the reuse of ECDHE keys, I don't think there is much of a problem with using the same key again for an ephemeral exchange over the course of, say, a minute or an hour, which is what the implementations that are doing this reuse to avoid having to do 2 exponentiations for every handshake are doing. I also think there's no reason to use finite field Diffie-Hellman. The keys are incredibly big. It's incredibly slow. We should just ban it entirely.
Sounds good. Any other questions? Okay. Looks like we'll continue discussing this, and I'll hand it back to the chairs.
Okay, thanks, Kirk. Let's move on to, I think our next was TLS-POK. No Owen or Dan.
Hey, Joe, I think this is the later version of the slide deck that Sean uploaded.
Yeah.
Oh, later version.
Yeah, I uploaded it in the session.
Is that going to be 01? Is that the right one? Looks the same.
Yeah.
Okay.
Okay, so give some context here. So this is presented at Immune at 109, and the goal here is to reuse some of the mechanisms that are used by the Wi-Fi Alliance device provisioning profile, and then use them for a wired device. So go on to the next slide. Some context: Wi-Fi Alliance DPP protocol defines how a supplicant bootstrap key pair can be used to bootstrap a supplicant against the Wi-Fi network. It gives a guarantee to the supplicant or the device that it's connecting to a network that knows it's bootstrap public key, and it gives a guarantee to the network that the device that's connecting is a holder of the associated private key. DPP defines a format for the bootstrap public key. It's encoded using an ASIN1 sequence from RFC 5280. It's a raw key pair. It doesn't necessarily have to be part of a PKI. It may be static and embedded in the supplicant, or it may be printed on a QR label or included in a BOM, etc., or it could be dynamically generated if the supplicant has a mechanism for generating and displaying a bootstrap key. So the bootstrap key is a public-private key pair, and the public key is provisioned on the network. So we want to reuse the same bootstrap public-private key pair mechanism to enable the device to securely bootstrap against a wired network using ETLS by TLS extension. And we want to reuse the same DPP bootstrap key format, which means that if a device has a DPP key, a bootstrap key provisioned and available on a QR code or on a BOM or whatever, the exact same bootstrap key can be used for both wired and a Wi-Fi bootstrap. Next slide. So outlining DPP, the public bootstrap key is provisioned in the DPP configurator. And the configurator, it's typically a mobile app for the DPP use case, but it could also be embedded in a Wi-Fi access point. Proof of knowledge takes place via Diffie-Hellman using the bootstrap key and the configurator's ephemeral key. So the supplicant proves that it knows the private key bootstrap key pair, and the configurator proves it knows the public key bootstrap key pair. A secure channel is established based on that Diffie-Hellman, and then network information can be securely exchanged, which allows the supplicants to securely connect to the network. Next slide. So what we want to do is reuse the DPP bootstrap key pair for wired LAN use cases. So the public key of the bootstrap key is scanned into the network and known to the AAA server or the TLS server. And the mutual proof that needs to take place is the device wants the network to prove that it knows its bootstrap public key, and the network wants the device to prove that it knows the associated private key. And that's pretty easy to achieve by exchanging two sets of Diffie-Hellman keys in the client hello server hello. So the standard key share, which both sides generate ephemeral key pairs, and then what we were defining in this draft is a bootstrap extension where the client sends a one-way hash of its public key to the server. The server can use that to look up the full public key, and then the server will generate a second ephemeral key and exchange that ephemeral key in its server hello. So both Diffie-Hellman calculations are injected into the key schedule, and we're proposing we just piggyback on top of the Hoyland mechanism for extended key schedule. Next slide. So this is just taken straight from the draft. It shows the TLS extensions that we're defining. So the bootstrap key extension in the client hello, what happens is the client sends a hash of its public key to the server. The server uses that to look up, and then the server will respond with a ephemeral key exchange in the response. So then in the client hello, you can see the bootstrap key share been sent, and that would include just the bootstrap key identifier, which is the hash, and then in the server hello response, the server will respond with two ephemeral Diffie-Hellmans, one in the key share, one in the bootstrap key share. And you can see in the right hand side there, we're just injecting the bootstrap key input, which is the Diffie-Hellman as a result of that semi-static Diffie-Hellman exchange into the key schedule using the Hoyland draft. Next slide. So what that means is that if you have a supplicant that has a bootstrap public key either statically embedded in it or dynamically generated if the supplicant has an output device, then that bootstrap key can be used for onboarding the device against both a Wi-Fi network using DPP and against a wired network using this TLS proof of knowledge extension on top of EAP. Next slide. So the security considerations, it leverages the TLS handshake with no esoteric cryptography. The existing TLS security proofs should be applicable. We're proposing just piggybacking on top of the Hoyland key extended key schedule draft. And for bootstrap key security, the TLS proof of knowledge has the exact same security stance as DPP with respect to bootstrap keys. And with DPP, if an attacker knows the bootstrap public key of the device you're trying to bootstrap, that attacker can then bootstrap that device against their network. The same holds true for this. For TLS proof of knowledge, if you know the bootstrap public key, you can claim the device. So it's exactly the same posture as DPP. Next slide. So there is working code built on top of the Golang Mint stack. Next slide. So we presented this as EMU at 109 and those general consensus to progress this work. There's 3 general work areas. There's some trivial TLS extensions to transport the bootstrap key identifier and the extra Diffie-Hellman key pair. The key schedule enhancements, the Hoyland draft should take care of that. And then there will be some EAP and TEAP extensions required to leverage a new TLS proof of knowledge handshake. And the open questions we have is how many documents do we need to close this work off? We've the Hoyland draft for the extended key schedule, but for the work we want to define, there's 2 major pieces of work left. One is defining the TLS extensions, and 2 is defining exactly how you leverage those TLS extensions inside in an EAP exchange. So should that be one document that falls under EMU? Should it be a short TLS working group draft that just defines the TLS extensions? And those are the open questions we have. And when we discussed this at EMU, the recommendation was to present to TLS and get some feedback from here. And I think that's the last slide.
Watson, were you in the queue still?
So I rejoined for this draft.
Okay, go ahead. You're first.
All right, Watson Lad, Cloudflare, in case anybody didn't hear it. All right, so I do not think this draft actually uses the security properties of TLS. And the reason I think that is TLS was designed assuming the public key is public. If you were to do this with ECDSA and raw public keys instead of this funny DH pre-handshake thing, it would be totally broken because any attacker could look at the ECDSA signature, recompute the public key. So clearly it doesn't compose that way. And so now you have to answer the security question of, okay, well, how do you preserve that property when you're composing it with TLS, which wasn't designed to have this property? And I feel like there's a whole bunch of changes to TLS versus potentially defining a new handshake that uses an asymmetric secret keys, and then integrate as just another sort of authentication, mechanism inside.
Okay, I'll need to think about that. Because, well, we're just trying to mimic exactly what DPP does, which is the network proves to the server, the network proves to the device that it knows the public key, the bootstrap public key, without the bootstrap public key being transmitted in clear text over the wire from the client to the server. We're not really trying to use digital signatures over that public key at all. and this is kind of independent of using the it's independent of the client knowing the server certificate. You could still potentially do certificate-based authentication on top of this as well. It's kind of a second authentication mechanism that you would use.
Okay, Ecker, you're up.
So I'm not like persuaded that this has the same security properties as TLS at all. In particular, TLS always I think is a server, and the fact that you're not authenticating the server strikes me as having some like I'm not sure how to reason about that at all. And as Watson suggests, you know, this also is weirdly not generically composable. So I guess I'd like to Ben Kadick says, you know. We don't in the chat about like we don't really haven't analyzed DPP either. So I'd like to understand the requirements better. In particular, do you have to use exactly the same keying material which you're presently using, or can we have a different set of keying material? So in the email, I suggested, for instance, having a separate pre-shared key and as well as the client's key pair. Is that impermissible?
So, well, what we're trying to do is reuse exactly the same key pair that's on the DPP, that's defined for DPP, and could be printed on the label of the supplicant. So we're trying to piggyback on top of exactly what DPP has defined for the supplicant to bootstrap against a Wi-Fi network.
Oh, okay. Do you care which direction? Which do you care who is the client, who's the server?
So DPP allows the proof to happen in both directions, but this draft is just the client is just trying to satisfy.
Sorry. Do you care who's the TLS client? Who's the TLS server?
The supplicant is a TLS client.
Does it have to be?
If that's what you're asking. For this to work, I think the supplicant would have to be a TLS client, yes.
Why?
Because you're providing this.
I mean, the core design of this mechanism is, the TLS is designed to have mandatory server authentication, optional client authentication, and you're inverting that. You're inverting those invariants, and you're creating mandatory client authentication, optional server authentication, and that is the source of the disruption you request in the single state machine. And so the question I'm asking is, if you invert those and have the person who's authenticating be the supplicant, then it will work much better with the TLS state machine, and there eventually resolve this problem.
Okay, well then we need to think about how that. Okay. So that seems kind of strange as well, though, in that the client who is trying to connect to the network is going to turn around and be the server for the purposes of this exchange, and the client will advertise something to the network, and then the network would turn around and initiate a TLS handshake with the client.
So I mean, there's a bunch of chat about exactly what's happening in the chat, but the core design of TLS is that the public key authentication is done by the is done by the server and not necessarily by the client. And so you're not authenticating the server. The server's like, if you look at your handshake, the server like isn't signing. So it's just like this isn't. It's not really. It's like the same number of errors as TLS, but it's not TLS at all. In any case, like we're probably not going to resolve this here. So let me just take a step back, which is like this is nowhere near ready for adoption. What we need is a clear description of the actual requirements, so we can actually try to design something that like works with TLS and doesn't just blow the state machine up. So I think like I'd like to take a step back from this particular proposal and understand the requirements.
Okay.
So the queue needs to be really quick because we had about 2 minutes left on this topic. So thanks.
I assume I'm next in the queue. Just with respect to the security properties, I actually agree with Eka's analysis that, or Watson's, that the secret public key changes things. But the purpose of the draft this is based on is such that it shouldn't be possible to weaken the TLS guarantees no matter what you stick in there. And so this should avoid the need for as much analysis as you might otherwise think.
Okay, this is Scott Fleur. Basically, one of the things is to note is that this is a different use of cryptography, and it really needs to undergo some CFRG analysis.
Okay, so I'll take all that. Okay, this needs a lot more work.
Hi, this is Hannes. A quick comment. So while it's not ready for working group last call yet, I think this is useful work and should be done in the IETF and the TLS working group in particular, because after reading the DPP specification, I realized that it basically replicates a lot of the things in the TLS handshake for no good reason, and all these devices then have to, for onboarding, have to then implement all sorts of different protocols, which make it very difficult on lower end devices.
Thanks for the presentation, Owen. I think there's more to discuss on this particular topic, which we'll have to take to the list. So next up, we'll have opaque and TLS 1.3. Is Sophia on?
Yes. So thank you very much, Joseph, for allowing me to speak here. So today, on behalf of the authors, which are Nick Sullivan and Christopher Wood, I'm going to present a draft that basically aims at integrating opaque with TLS 1.3. My name is Sophia, and I'm from Cloudflare. Next slide, please. Is it working? Okay. Oh, yes. Okay. Thank you. So just to give a little bit of context, what is opaque? Opaque is a new mutual authentication method that is currently being standardized by CFRG, and you can find it in the draft that I have listed here. And as I said, it's a mutual authentication method that enables the establishment of an authenticated cryptographic key between a client and a server based on a user's password without ever revealing the password to servers or other entities other than the client machine. And the idea of opaque is basically trying to solve the problem that most of the time passwords are stored in servers, and when the server gets compromised, then the passwords get compromised as well. As it is written right now, opaque consists in two phases. The first one is the registration phase, in which obviously a user is registering the password, but not the password itself, but rather something generated out of it, and is stored in the server as encrypted credential. The results of this mechanism also generate a key pair for the client and for the server as well, which is important because it's an important part that is going to be put into the second phase of the protocol. The second phase of the protocol is the authentication phase, which is the one that we are interested in it today. Basically, the idea is that in the authentication phase, the client proves the knowledge of the password to the server, and both client and the servers agree on a mutually authenticated shared secret. So the goal of the draft I'm presenting today is to combine password-based authentication with traditional PKI-based authentication. Next slide, please. Okay. So what are the ideas? As already defined a little bit what the authentication phase is, but it basically consists on a concurrent OPRF mechanism and a key exchange flow. And as I said, one of the results of the registration phase is that you are going to have a key pair for the client and the server. So the idea in order to achieve the proving of the knowledge of the password by the client, and that both the client and the server agree on a mutually authenticated shared secret, is to use TLS for that. And how we combine this in TLS is by listing two mechanisms, the first one called opaque sign, and the second one called opaque hex. In opaque sign, basically the idea is to have it as part of the handshake itself, And the key pairs that were generated for the client and for the server act as signing keys, and they are going to be used for the authentication in the TLS handshake. This mechanism cannot be used in conjunction with certificate-based authentication. If it's needed to be used with, in conjunction with certificate-based authentication, then it can be used as a post-handshake mechanism, in which first you will have a TLS handshake in which you authenticated with a certificate, and after that, you can use exported authenticators to authenticate it with a password. The second mechanism is called OpaqueX, and in this one is also part of the handshake, but the key pairs that were generated for the client and for the server will not be used for signing, but rather they will be Diffie-Hellman keys. And the idea is to generate a shared secret. The secret is fed into the key schedule for the handshake, which uses certificate-based authentication and establishes the shared key using Diffie-Hellman. In this case, there's no unilateral authentication because mutual authentication is only achieved after explicitly processing the finished messages. And these two mechanisms are as an extension that gets advertised in the client hello and all the messages. Next slide, please. Okay, just to finalize, there's still some need to actually look into the security privacy considerations that this extension will actually have. One of the considerations what we're thinking about in the privacy perspective is that, of course, with this mechanism, the identity of the client is not hidden because you send the identity of the client as part of the extension in the client hello message. This could be a problem if you're using this mechanism with exported authenticators. You don't have this problem because at the beginning you already have TLS connection when you're using this mechanism. You can further use something like encrypted client hello to hide the identity. And if you want to look at the draft location, it is found here. With that, thank you very much, and take any questions or discussions, comments if there are any. Thank you. And I'm supposed to be calling them. Yeah, okay. So you go, Benjamin.
Hi, this has been, I had typed this into the chat, but if you could go back to slide 3. I'm not sure I quite understood whether or not. So it seems to be saying, well, I guess my real question is, can I use Opaque to authenticate the client using the password, but then use the certificate to authenticate the server in the same handshake?
No, what you will have first is that you will have a certificate-based authentication, and then you can use Opaque for the post-handshake process to authenticate.
Okay, thank you.
It could be mutual, but yeah, okay.
Yeah.
So I'd like to get a sense of how many people have read this draft, so I'm going to do a show of hands poll here, because I think I figured out how to do it. So let's do that. Keep asking questions, but just to let you know, it's going, because we've talked about this a couple times before. Victor, go ahead. Nope, no. All right, so I think that's probably good. We had about 7 people raise their hand that they did read it, and about 23 who didn't out of 94. I guess what I want to do is, because we've talked about this a couple times, is make sure that people start to review this and that we see whether or not the working group is going to be interested in adopting this on the list. I believe if there's no other, nobody else wants to say anything, that's it for our session.
I think that's it. Thank you, everybody.
Thanks all.